Hey, what's going on, YouTube gang? This video is actually answering a student question. Um, Technically an alumni, but we're all students, right? It's a lifelong journey, this development process and learning and coding and whatnot. So we had a mentor session and they have a project built on our Covalence boilerplate. So this individual went through our program and used our boilerplate to build several CRUD applications, as our labs have you learn from and use and build. And they've actually built a business off of a server with a MySQL database with a React front end using our bare bones, big keyword there, boilerplate. And they're starting to get to the point where they need to actually start figuring out how to optimize the Webpack bundler more and begin that process in the production world of okay, splitting hairs and trying to figure out where they can speed things up and how they can improve things. We had a mentor session where I went over how everything was pieced together and some ideas for what they could do, and they had an interest in simply splitting the project. Their goal is to create a progressive web app and maybe even eventually a native app for what they're doing, and they want to utilize push notifications specifically, which is why they're looking towards to do this. They're wondering how can they take this repository, which is a monorepo with an Express server and a React front end being sent from the same Express server in one port and location, and they want to know how they can split that into a standalone REST API and then whatever front end they choose to build. It could be a React website with Create React App or Vite or Next, or it could be a progressive web app with some of those technologies, or React Native, for example, or they can use React Native to build an entire native app. The point is, they want to take it from a mono repository, a big monorepo, into a headless REST API, and then whatever front end they want, forming a more decoupled structure. And theoretically, they could just make this an entire headless API, right? Make it their own content management system for their entire, be the backbone for their entire project, and then choose whatever front end crap they want. So this will be a two-part series where I focus on the first video, building out the server portion, how to split that out from our boilerplate. And the second part of the video will be me probably experimenting with Vite for the first time. I might do some coding beforehand on the video so you don't have 2 hours of me bumbling around with new technology, but nevertheless, it should be a lot of fun getting a front end built out. And again, by front end, I mean we're taking our boilerplate, which is a singular component that says hello world via a REST API call. So a fetch request call, right? So I want to take that and just have it be split into two projects, so the student that asked me this question and their developers on their staff can, well, take what our boilerplate does, split it into two, and have a successful split. Okay, so yeah, that's the goal of this video series. Hopefully it's I know it's niche content meant for an individual student that asked me a cool question, but I figured I can make this into a YouTube video because who knows, 2, 3, 4 years down the line, someone that runs into a similar problem could come here and be like, oh, this saved my rear. Thank you so much for making this video. Because that's how I feel when I find answers that are 3 years old marked as answered on Stack Overflow. I'm like, thank you, blessed person, for all those years ago answering this question. So yeah, or again, this might be good for alumni that have freshly graduated from our course that have their capstone project built on our boilerplate and want to make it a bit more robust. This is something you could also watch and get some information from. So basically, our boilerplate works as the following. Everything just runs on localhost 3000. We have built out an Express server that, using the Express static middleware, will serve a built SPA, single page application. We use TypeScript and Webpack to compile and bundle out all of our React code into a singular app.js file, so no code splitting and things like that. Again, it's called bare bones for a reason. So all that is jammed into a singular app.js. It's loaded in a singular index HTML, and then all that juicy React code, typically with React Router DOM, will be navigating around and making various fetch requests that will come back to the same server that has served this website, right? And so this is how it's currently built out, and back here could be MySQL, MongoDB, doesn't matter. More than likely it'd be MySQL because this is the question that the student asked me. This is the tech stack they're using, the MERN tech stack, where M is for MySQL rather than Mongo. This is what our boilerplate does in a nutshell. Help, I'm in a nutshell. This is all it does. And the goal of this little series here will be to take what it does here and split it into two pieces. So we're going to have repository 1 that will be our server-side code. We're going to have repository 2 that will be whatever front end we decide to go with, which will be part 2 of this video series. For instance, this one all ran on localhost 3000, so when the React website had to make requests to the server, we could just use the root path by saying /API/ chirps /users. Like we didn't have to specify any kind of root URL because whenever this was in local development, it would default to the root address of localhost:3000/API/chirps that would go get those from the server, that would then send them to our website and inform what it would look like. But in this project, we will have to have some environment variables for both development and production because we're going to be coding our own Express server. Now, there are plenty of libraries that you could find on npm.js or even like there are plenty of ways you could bootstrap a very solid REST API server via Express and something like Feathers.js. There's one with like a lion logo. I forget what it's called. I think it's Nest.js. But this student already has a crap ton of code already written out in the way they had learned it, and well, them and their team had written it out. So I'm going to go ahead and choose not to use some kind of bootstrapped library for Express. I'm going to show you how we're going to just transfer over all that code manually, and we're going to code it ourselves, write the TS config ourselves, and all that kind of fun stuff. Now, that's going to be deployed on its own address, like my super cool server.com or something like that, or in local it'll be localhost:8080 running on its own unique port. Then we're going to choose on the front end something like create React app. I thought I'm going to mess around with Vite for this video series. It should be kind of fun figuring out how that works. And what it's going to do is it's going to be its own repository and its own deployment. So the student will now have 2 deployments to worry about, and eventually a third one if they're going to leave this as their website and they're going to choose to maybe use React Native or create React app to make a progressive web application so they can start utilizing things like push notifications, which is what has pushed, ironically, them towards this decision. So yeah, this is what the structure is going to look like. We're going to have 2 directories to worry about, 2 GitHub repositories to worry about. We're going to write our own Express server in this video. In the next video, we're going to just kind of see how we can transfer the front-end code from our boilerplate on over to something else. And that's it. That's the basics of what's going on here in this super cool PowerPoint that I made in like 20 minutes. So that's the visual goal. Let's get underway. All right, so I have done nothing other than we're going to clone our boilerplate. I have a command for this called boiler. You would just do your git clone and use our boilerplate link, which I'll remember to include a description below for non-students of our course. Yeah, so boiler, we'll call it a split me, please. Beautiful name. We're going to do cd into this directory right here, and I'm going to go ahead and run an npm install to get all dependencies installed to show y'all what a fresh, clean build looks like. Yeah, Webpack should be running all the TypeScript code to compile and bundle up. Booyah. Then we're going to hit him up with an npm, if I can type, run dev, which should also call Webpack, so that was a little redundant, but whatever. I'm going to head to our beautiful website here on my other monitor and swing it on over. Looks good. Compiled successfully. And she is running. There is our awesome website right here that just says hello world. The hello is written into React TypeScript, and the world is via state that is fetched from its own server. So our lovely simple application here has state of world, which was again fetched from our server. So yeah, taking a look at the code for this thing here. I'm going to go ahead and stop that and open up the code editor and need to readjust some stuff here as I was doing some, whatever I code, I have things all over my multiple monitors. So, I always have everything zoomed out and I always forget before I record to make sure the zoom in levels are correct. But like I said, our project structure here has the client, which is our React code we were looking at here, where it fetches that greeting from an API path of /API/hello. And then we have our server-side code, which is a very, again, the students is more complicated than this, but I'm showing them how they would fundamentally split this project into 2 in an effective and efficient manner, and they can take that logic and run with it from there. So yeah, we have a simple server with a simple router for our React project to fetch there. We serve that static asset, which is the public folder, which has our index HTML and our compiled and bundled React code, and then this app just uses the API router and runs on port 3000 unless otherwise specified by an environment variable. So yeah, it's really simple, so let's see if we can figure this one out. So like I said, we need to split this server into its own project, and the student might be wondering what exactly has to come with it, because the way we have it written here in this monorepo, we do bundle the server-side code to output so Nodemon can run it. But we really don't need to do that. I mean, it's a little overkill to be bundling our server-side code since the purpose of bundling, especially for front-end code, is to make sure it's transpiled into safe, browser-friendly JavaScript, and that multiple files are split into smaller parts for faster loading and things like that. That's important for client side because you don't know where your website might be running. An old iPhone, a new Android, an old Mac, a new PC, who knows where it's running. So you kind of have to make sure you optimize for making sure it runs fast on all kinds of machines. Whereas a server, you're going to deploy and it's going to be running on either your own deployed like local server if you build like your own server out, or if you deploy it to Heroku, which I know this student has and probably pays for something higher than the hobbyist tier. They're going to give you some pretty good infrastructure where your server code's going to be running. There's no point to really bundle it all up. It just needs to be, well, compiled, outputted, and ran as efficiently as possible. So we're going to avoid bundling on our server-side process to keep this one simple. So we already know we can ditch a lot of that stuff right there, and we might be grabbing some of this client config or utilizing whatever Vite or Create React app, for example, would provide for us. But yeah, again, trying to split this apart first time around, not so easy. If you're not familiar with how the whole process really works, right? So let's dive on in. I'm going to make a new window here in Commander or your terminal, whatever shell you're using, doesn't really matter. I'm going to make a new window to the right-hand side here. And here is where I'm going to, in my helping students folder, just so they're equal here, I'm going to make a new project that will end up being a new repository that I'll be maintaining as my server, so on and so forth. So I'm going to make a new directory, and I guess we'll call this Split Server API, right? So we're going to cd into Split Server API. It's going to represent, surprise, surprise, the entire new server that we are splitting apart and configuring from scratch here. So I will go ahead and probably make a few files to get this sucker started. I am going to make a source directory because that's where we're going to be writing out all of our server-side source code. We're going to have our gitignore. We're going to need... Eventually, I'll be using NodeMon, so I'm going to actually have, rather than pass a bunch of flags to NodeMon when it comes to my development process, I'm going to choose to instead use a NodeMon JSON where I can specify NodeMon and customize with options how it runs and what files and folders it looks out for. I'm going to make our .env file because the student is clearly going to have that for the size of their server, and I'll go ahead and I should just use TypeScript to auto-generate this, but I'm going to try and touch upon a couple properties in the TS config as we write it out ourselves here. Okay, we also need to make this a node project. Goodness gracious, I'm going to do a node, npm init, and rather than doing a -y, we'll answer a couple of these questions here. Yeah, Split Server API is fine for a package name, version 1.0 for now. Description, a REST API split from our boilerplate. The entry point will be probably our source server. Actually, yeah, it'll be source server.ts will technically be our entry point, or theoretically it'll be like a compiled version of it, but whatever, it doesn't matter. No test command, I don't really care about that for now. Git repository, I'll attach one later. Keywords, REST API, headless API, splitting monorepo, just some fun phrases here. Author, we're going to say Cool Hand Luke. License ISC is fine. That's fine. Yes. Okay, cool. So, open up the code editor for this one. It'll be separate. And voila, looking good in the neighborhood. Right, so first things first, I will specify we're going to have a port of 3000 for our environment variable, or not 3000, we're going to do 8080 like my video recommended, right? So right away, this is the big difference, student that asked this question, you're watching. We are running this on its own port. This will also represent its own deployed address. Now, you could look into subdomains and things like that, but to make things easy, you might just look into deploying it on its own address and its own URL, and then the website on its own deployment with its own URL and domain and stuff like that. So immediately, that's the big difference here, right? We're going to be having to run 2 terminals in our development process locally in order to have this, unless you're going to be talking to your production server, which I don't think you want to do in local development and testing. Righto, so that's what's going to go inside of our .env right there. At the bare minimum, as always in your gitignore, you should include node modules and .env, for example. But I have one that I tend to copy and paste between projects. This one, I think I looked up like good gitignore or something like that and got all this code from it on. So I'll have this pushed to GitHub, so y'all, and links in the description below, so y'all can go and find it and copy and paste it. But at bare minimum, don't push node modules to GitHub. bad form, bad practice. You're going to waste your time and your bandwidth, as well as GitHub's. Not that that matters because Microsoft has enough money to handle that. But, and then .env, making sure that is not pushed into GitHub because you don't want to accidentally push your API keys into GitHub and cause yourself a huge mess like I've seen my students do in the past, despite multiple warnings. So I want to paste my lovely GitHub git ignore that I found that says like, hey, this is all cool stuff that we're going to, again, this is like, I found this and copied and pasted it in here because it's just good to have this. So I'll have this in the repository. I'll have it pushed to GitHub. Link in the description below so y'all can also copy and paste it if you want to use this lovely git ignore I found here, right? All right. Moving on. So that's our git ignore. That's our .env. Now, granted, they're going to have a lot more API keys than me, but I'm keeping it as simple as possible. So, okay. Now, for packages, we currently have nothing installed, and we're going to be installing a couple packages and running a couple scripts to get this sucker working out. So 2 scripts we're going to be working with real quick. We're going to have a build script, which will be taking TypeScript and asking it to compile and output into what's called a dist folder, or like distribution, distributable. It'll be like the compiled code of our server that will be on Heroku. Now, typically, you don't compile it locally, push it to GitHub, and then deploy that repo to Heroku, for example, and have it run that dist code. A lot of the times, you'll have your Heroku server build it for you. So it will look for a build script, and it will build and compile our source code into a dist folder that will actually be running in production. So that's how we're going to build it. That's also going to be similar to how our start script is going to work. Now, I'm going to leave this open-ended because there are some seriously cool tools, such as PM2, to look into to running a production server efficiently with throttling and load balancing, all that fun kind of stuff as well. Yeah, but for now, I'm just going to run it just via node, and it will be dist server.js after everything is compiled and outputted as it should be. That's how it's going to start. And for our development process, we're going to have nodemon. And again, normally this is where I would pass additional flags to nodemon to customize its options and how it runs. We're going to be doing that from our nodemon JSON instead. So let's head over there in just a second. Yeah, so back to it, like I was talking about, we're heading into our nodemon JSON file where it's going to be, again, JSON, so our object notation here, and we're going to have a couple of options we're going to customize its process with. We're going to have a watch flag that can take an array of directories, patterns, globs, whatever you want it to look for. In our case, we're going to say just look and watch for everything in the source directory, so this is how nodemon will know to restart the whole process should it detect any changes anywhere in our source code. That makes sense. If we've changed something on our server, we probably want it to restart with our new server code rather than us having to stop and restart it constantly ourselves. Something else that's also convenient and our boilerplate doesn't do for a student that asked this question that spawned this video, we're going to have a .env watch here as well. That way, when you change environment variables, nodemon will also restart. That way, you don't have to stop and start the entire process over again for it to detect the new env file changes. Very nifty quality of life inclusion right there. We're also going to have it watch for certain extensions. We're going to say JS/TS/JSON. That makes sense. If we have any JSON config files and things like that, we also might want them to watch for that. We're going to tell it to ignore a particular pattern here. And again, this is for whenever you end up including testing in your project, you'll probably have something akin to that as well. Yeah, that's for typically files that will contain unit tests and things like that. You're going to be ignoring that for now because as we change our tests, we're going to be running our own testing command for that, and we don't want nodemon restarting constantly as we're rewriting tests or changing tests and things like that. And then what's going to ultimately execute, rather than just running a simple nodemon, we're going to ask it to run the following. We're not going to be running it. We're going to be transpiling our code directly. That way we can speed up our development process. We're going to be using a command via tsnode, a package we're going to be installing, which I think the student already has. That's going to ask it to transpile only. That way it doesn't actually compile everything out. This will be faster, just transpiling everything in place. And we're going to tell it to do so via source server.ts like that for this particular example is what we're going to be looking to do. So that right there. Do we need that? Yeah, I think we need that if I'm going to do relative pathing. Yeah, so we're going to say look in the source directory, find that server TS file, and that's how we're going to be executing this project via nodemon and all the rules it's going to have within. And you can, again, look up additional things you can include here in your nodemon configuration. It's a lot nicer to do it this way rather than passing a gorillion flags here in our package.json script. So that concludes our journey into nodemon JSON right here. And now we're going to go back to our package.json and discuss a couple of things we're going to be adding here as well. So we need to actually install some dependencies and development dependencies to get this sucker up and running. So in our project here, we're going to say, well, we're going to need what? Definitely nodemon. I'm going to install that as a dev dependency. Yeah, I mean, this is where, like, you know, I follow. Sometimes I will add everything into dev dependent, or I will try and split things between dependencies and dev dependencies. Other times, just add them all into dependencies. We're going to take that route today out of almost laziness. I'm going to add nodemon as a dev dependency for now. There we go. Beautiful stuff. And then from there, I'm going to just add everything else as a normal dependency from there. So we're definitely going to need Express, and we're going to need the @typings for Express as well. Clearly, that's how our server is going to be running here. Just to add a couple of, middlewares, I always include my boy Morgan in a lot of my Express projects. That way we can use it for logging information to our server or a server log file in production, things like that. Huge fan of Morgan and its typings right there. We're going to need to add cores to this particular project as well, because a cross-origin resource share is blocked by browsers by default for, I guess, safety and consistency reasons. So we didn't have to worry about that in our monorepo structure back in this project because the website was running on the same location as the same location origin as our server. So it was making a same origin request, which means we didn't have to worry about it. But our new server-side code will be a cross-origin request because our website on localhost 3000 will not be the same origin as localhost:8080. Browsers by default will block that, and we're going to have to include that that's okay via this cores middleware on our server here, right? From there, we should probably also have .env as well. We're going to include the typings for node. I think we're going to have @types node. That way we have that information available for our TypeScript buddy here. And from there, I mean, you can, whatever other middlewares you have aren't really that important. You'll look through your monorepo and pick out the server-side dependencies. Other middlewares like Helmet are popular. Clearly, you're going to be installing MySQL and its typings as well, and building out your DB config folder and things like that. Anything I'm missing still? I feel like I'm missing something. Yeah, TS node. I haven't installed that as a dependency yet, right? So let's install it. I will say, please install TS node as a dependency. Oh, and TypeScript. We haven't installed TypeScript yet, so there we go. Yeah, just building out our packages a few at a time here. So here we go. Got our lovely looking list of dependencies and our singular dev dependency just to have it kind of isolated there. But you can make the argument that these things are needed during development as well as production to make sure it gets compiled correctly. So I mean, I've seen arguments for either pattern of having these as dev dependencies and vice versa and whatnot. But yeah, I'll just add the multiple dependencies here, and I know nodemon's definitely just a development dependency in our case. So yeah, that's how we're going to build out the simplicity of our package.json. And now we're going to need to talk about our potential config options, because we do have a lot of potential choices we can go with here as for some development options that are good, some that are better, worse, and I can try and talk about them and their properties here. So in our TS config, we are going to build this sucker out. We're going to have some compiler options here in this object. We're going to have our include, and we're going to have an exclude as well. So in terms of excluding, just like typical, we're going to include node modules to play it safe. I'm sure there's like some rules, some like implicit stuff that happens and I'm not entirely familiar with or haven't researched properly, where like, hey, you might say you don't have to exclude that, I'll do that by default or something like that. I like to play it safe. I'm old school like that. What can I say? Same thing for this glob pattern. We're going to say look for any test.ts as well as for any like if we do have it written this way, we could do like a spec.ts as well to make sure that our tests and spec things are excluded from being compiled because they don't need to be compiled, right? And then for include, it's going to be everything from the source folder. So we're going to write this pattern here as well, like the following. Boom. Anything that matches that glob pattern, meaning every directory and subdirectory and file of the source folder should be included in this whole compiling process, right? That's how we're going to be having that written out there. Now, for the compiler options properties for our target, this is a massive update for us. We're going to say look for the target of the latest and greatest and coolest JavaScript. Now, this target may change depending on what version of Node is being ran on Heroku. You can go look at, or wherever you're being deployed at, you can go look at what version of Node that their server provides you if you're doing like a platform as a service. But if you're writing and deploying your own server locally that you're maintaining with its own address and things like that, then you can output and install whatever version of Node you need. But for now, I'll go ahead and write ES 2019 so it emits the latest and coolest JavaScript, right? Now, from there, our module resolution, we're going to be doing common.js. Common.js, which is typical for Node.js applications using that import-export structure, or syntax rather. It's going to be our module choice right there. For our output directory, like I said, we're going to have it make a dist folder for us, which I'm also going to make sure is somewhere in my git ignore. Like I said, this is a copy and paste one. I don't know if they have dist or not, but yeah, I'll just add it up here as build and be like, ignore the dist folder because that doesn't need to be pushed to production, or doesn't need to be pushed to GitHub in our git ignore right there. So yeah, back into our TS config. This is going to make that dist folder, and it's what's going to be compiled and ran on in production and not in development, because in development we're going to be transpiling only, not actually compiling all the way out. Now I flounder between strict, false, and true. Considering y'all have a ton of code already written in Express TypeScript, if you're the student, then I wouldn't be inclined to temporarily toggle this off to false to make sure you don't have a massive number of TypeScript errors hindering your ability to transfer a lot of code over and get it up and running fast. But over time, the bigger your server gets, I do recommend turning that to true. But there are ways you could customize options that the strict true flag has like underneath it, because there's like a whole bunch of options that strict true toggles on, but we could customize the process a little bit further than that. So for getting everything migrated over as painless as possible, we're going to go with the strict false on this one for now. From there, I like to always include an ES module interop of true. That way, that way we are allowing ourselves default imports from modules that have no default export, right? This is what saves us the effort of writing *as for all of our TypeScript imports and writing them into a nicer, cleaner import thing from thing, right? So it gives us a more natural and consistent syntax for importing common.js and AMD modules, right? Because not everyone has a default export, but sometimes you want to do an import default structure, and this is what allows us to do that. From there, we're going to do, I guess we can include skip libcheck. We're going to do a skip libcheck to true. This I will toggle between true or false depending on what my project's needs are. True means it will skip type checking declaration files like d.ts files. And it can help speed up the compiling process. And it's useful a lot of the times when you trust the types provided by your dependencies and you want to reduce build times, right? So that's what skip libcheck will do. You can toggle it on and off to see, especially depending on the size of your project, to see how fast the compiling process is true. But I know from our last mentor that some optimizations are starting to be needed at this point in your production process. So that's something that you can take into consideration. Just trust the types that are fine, and just have it compile a little bit faster in our coding process here, right? So I like this one especially, and this one may destroy you if you haven't been consistent, but making sure we have consistent casing and file names, so they're all like lowercase or hyphenated or something like that. This can save you a lot of headache if you are working across with multiple people, like one person working on a Linux machine, like my co-instructor Andrew, one person working on a Mac, one person working on a PC, being deployed to Lord knows where on Heroku. I don't know what the run. I mean, again, like the point is, like, not all operating systems treat file casing consistently, so that could be a huge nightmare in a collaborative project, especially. So using this tsconfig option to make sure everything is cased the same way is a very, very useful toggle to have true. But again, you might have to turn this one off to false temporarily. I think that's the default value anyway. But it has saved me some headache in the past, especially because I do have a Mac laptop that I will sometimes go to like a cafe to do some coding on, and I want to make sure that coming back to my Windows machine, I don't have file casing differences that will cause me a headache to try and figure out what went wrong. We're going to need to include our module resolution, right? And we're going to have it set to node right there. Our module resolutions will determine what strategy our resolved module, how our modules are going to resolve. And node is a strategy used by Node.js, surprise, surprise, which resolves modules based on folder structure and the presence of a package.json or index.js file, something we do all the time, utilizing that index.js file to, well, be the entry point for a directory when importing things, right? So that's how it's going to make sure it knows how to handle that type of import statement. From there, what else we got to have? We can have our resolve JSON module set to true. The resolve JSON module, I don't know if you're going to need this in particular, but it allows you to import JSONs as modules. So that way you can import a JSON file and have it load into your code and be imported and used just like any JavaScript or TypeScript file. I find that kind of useful, but I don't know if y'all have any JSON files for your project you really have to worry about. And then from there, we're going to have... yeah, this one we might not need to include here, but it is called, hold on, my notes. Yeah, it's called isolated modules. Ensure that each file can be safely transpiled without relying on other imports. So this is probably a good idea in the long run to mark as true and watch out for. It basically ensures that each file in our project is treated as a separate module. This prevents the use of global whole program knowledge, such as const enums and namespaces, making your code more compatible with tools like Babel. So this kind of just makes it more compatible with other tooling processes should you grow the need to have them. So for now, you can just not worry about it, but in the future, adding isolated modules flag as true would be a smart maneuver to help build this out more and more robustly and scale and fun stuff like that. So, these two bottom ones here, but I wanted to throw them in there for some information, keep that in mind as I move forward in the scale and size of this project. But at a bare minimum, that should be good enough for our tsconfig here to do its job. And then from there, let's go ahead and build out some of our first typical stuff, our config folder, our server.ts, and we had a routes.ts. Remember, the point is here that I'm just trying to start migrating over all these files. And theoretically, I should be able just to migrate over and do some quick changes on our server-side code. So in y'all's case, it might be some file and folder dragging and dropping. In my case, I'll be copying and pasting from the appropriate server and route files. We're going to have our index.ts inside of our config. We're going to make sure that we can do an import.env from .env. Now, again, I don't have to do asterisk as, is because I chose that ES module interop, allowing me to do that to make sure every kind of package I've downloaded that doesn't have a default export can be treated as if it does. So that's why we can get away with our .env and not asterisk as .env. I'm going to ask .env to be usable within here, and we're going to do now, I tend to avoid default exports in my personal projects as I liked having named exports, but I know a lot of y'all probably have code that you learn from our curriculum. So, and again, if that's a pattern you have on this project, just stick to it. So we're going to treat it that way. And I'll say maybe the app has a port that will come from that process environment variable called port right there. So that I can now reference a port value that I probably should also parse into a number, because that is a possibility that's going to happen right there. So I'm going to say, make sure you process because the value read from the environment variable file will be a string, and I want to make sure that my types for the Express app, which is probably expecting a number for my port, is being processed there correctly. So we're going to save that, and that should be good enough to test our .env project here. From there, like I had mentioned, I'm going to go over to Split Me Please, my other project. This is my server.ts, copy, and paste into the server. Fix that right there. Oh, I called it route and not routes.ts. My bad. Typos. And then from there, I'm going to go back to Split Me Please, grab the routes file, copy and paste it, and we're going to paste it back into the split server, and we can remove the asterisk as style import. And there we go. We should have our lovely little router ready to go here, our server ready to go here. And we don't have any public folder here, so I can get rid of that middleware. No problem. I'll add my other middlewares here in just a moment. I will, however, be importing config from config, and then down yonder, rather than passing port in directly, we're going to pass in config.app.port to make sure it's there. App listen. Yeah, it's looking for a port number, so you'd have some TypeScript trouble should you had not converted it to a number and left it as a string there. So that's just to avoid that issue. Same thing for over here in the console log. Port will be config app port. So there we go. That is our transferred over code into our new standalone API with some cool configurations added to it. Let's see if she works or not. So we're going to do an npm run dev in this folder, if I can learn to type. There we go. A little coffee never hurt anybody. Check it out. We have it transpiled already right here down on listening on port 8080. And yeah, cannot get homepage because they don't have that, but you might now you can actually include like global error handlers and things like that as well. But more importantly, if I go to API/hello, we get world as our JSON response as coded by our lovely server here, which is what I like to see. What I like to see. Let's go. Now, like I was mentioning, pretend back over here in Split Me Please, we still have our front end going. We can pretend this is Vite or Create React App or whatever else running on this side. And now we have to change our requests from our code. So I'm back in Split Me Please, which is the original server that we had written, the monorepo that you would have. We would look at our client-side code, and now we would have to do, for example, this is not what I recommend, but let's see what happens. Because clearly, you don't want to have to handwrite this into every fetch request, so you're going, Vite, Create React App, and all those things typically do provide environment variables for client-side, which, again, they are not hidden, all right? If it runs in the client, the value is accessible, but the client-side environment variables are good for just toggling a variable, such as this root URL being localhost :8080 versus being my deployed server API.com, right? So you're not going to be hard coding this root address into all of your fetch requests. You should have some kind of fetching utility, whether it's a library or a service you've written yourself, where you have a base URL variable that you can toggle between development and production. But this is a request we want to make. We want our React side code to now be making requests to our separate headless server, and that's the request it's going to make now. Now we saw it was no problem from the browser itself right yonder, but if we try to do this from our original website code running on localhost :8080, not what I expected to see. I figured it was going to give us a CORS problem, but for some reason I didn't get one, which is interesting. Yeah. All right. Well, in deployed world, I know you're going to worry about CORS problems. Did I save the file? I didn't. That's why I was like, that's weird. I'm like, we should have gotten a CORS across origin resource share issues. Let's save the code. It's going to recompile on the left-hand side now and refresh it. And there we go. That's what I expected to see. That's why I was just like, did the browser change the rules? No. All the browsers are wrong, and I'm right. Turns out I was wrong. I just forgot to save the file. But yeah, that's what I expected to see. The world cannot appear now because we are blocked from accessing a fetch request to :8080, right? Because localhost 3000 is a different origin than localhost 8080 and has been blocked by a browser's core policy. No access control allow origin, right? So this is now blocked by our server. So we need to go back to our new server-side code. We're going to be importing cores from cores, and we're going to be including that as a top level middleware. This is the minimum we have to get away with to make this work. Save it. It should retranspile very quickly for development purposes. We can go back to our website, refresh it, and voila, we are now allowed to make those requests. That's what you're going to have to do to make sure all this ends up working that way. So yeah, honestly, I think that about wraps up the majority, like the fundamentals of what you're going to have to do in order to copy over all your goofy, crazy, lovely, juicy server-side code into our new project. We're going to deploy this and push this to GitHub. And yeah, if you have follow-up questions, let me know in the comments down below for any just YouTubers stumbling upon this little tutorial. The student that asked this video, just feel free to DM me in Discord, and I can produce any additional content you want. And in the next video, you'll see me taking this client-side code and moving it to somewhere else to deploy and mess with it. So after this video, I'll go ahead and push this split server API to a repo and have it in the description linked below, so you can copy my gitignore or find your own if you want to, or just to see, rather than have to like scroll this video to see what I did and where, you can instead just choose to go to the repository and copy some of the settings, or look at the settings I have there directly, right? So yeah, that rounds it out for this video. I thank everyone for watching, especially the student that asked for this video in this little series in question. Hopefully this clarified a bit more of how the whole process works and how, well, development as in general and DevOps works, right? So I'll see y'all in the next video. Remember to like, comment, and subscribe, all that juicy, fun YouTube stuff. I love making videos, so y'all get in the comments if you have any questions. I'll be happy to try and make some content out of it. So see y'all in the next one where we cover the client-side code.